Alright, in this lesson we're going to look at our last technique for integration by parts, which is tabular integration. We'll use tabular integration whenever we have a polynomial, a higher order polynomial paired with an exponential or trigonometric function. All the problems we do with tabular integration we can do with multi-step integration by parts. The nice thing about tabular integration is it saves us a lot of writing in finding our answer. And a lot of lines of work. So here's how it works. What we do is we organize the information into 3 columns. The leftmost column contains u and all of its derivatives, all the way down to 0. We want to take the derivatives of that polynomial all the way down to 0. And I will say in this, I write my tables a little differently than I've seen other people write them elsewhere. But I write them where I write u and its derivatives, and then I skip a line in the table in between each one, and that's so that I have proper alignment for my middle column. My middle column contains alternating plus or minus signs, starting with the plus sign. And you see that here. And then my rightmost column contains dv and all of its integrals. And we make that long enough so that the integrals go all the way down to the bottom here where we stopped our derivatives column. Okay? So once we've written those out, it's actually quite easy to do tabular integration. Here in example 1, we're finding the integral of x to the 4th e to the x. We take the polynomial, we write that and all its derivatives in the left-hand column, as you see here. Okay, so all I did there was take all the derivatives of x to the 4th. And we take the e to the x, since that's our dv, and we write it and all its integrals in the right-hand column over here. We set up our alternating plus or minus signs. And now we're basically done with the process, and all we need to do is understand how to get each term. And in order to get each term, all we're going to do is we're going to multiply down the diagonals. So we're going to multiply x to the 4th with a plus sign and an e to the x. And that gives us our first term. And then we're going to multiply 4x to the 3rd with a minus sign and an e to the x. And that gives us our second term. And we're going to multiply 12x squared with a plus sign and then e to the x. And that gives us our third term. Now, I'm thinking you've probably caught on by now. We're going to multiply 4x with a minus sign, and that gives us our fourth term. And we're going to keep doing that until we get to the bottom of this right-hand column. It gives us our fifth term. And then we'll write our constant of integration. And that's how we do tabular integration. Alright, let's go ahead and do one from scratch. We're going to find the integral of x to the 3rd times x dx using tabular integration. So I'm going to set up my table. I'll move it a little too wide there. So we've got u and derivatives, dv and integrals. Okay, so u is going to be x to the 3rd, and then the blank, and the derivative of that is 3x squared, leave the blank, derivative of that is 6x, and leave the blank, derivative of that is 6, and leave the blank, and the derivative of 6 is 0. And then dv and its integrals. dv there is sine of x. The integral of sine of x is negative cosine. The integral of negative cosine is negative sine. The integral of negative sine is positive cosine. And, pardon me, did I just say derivative? I meant integral. The integral of cosine of x is sine of x. Okay, so we're just taking integrals up the ladder there. And then in the middle columns, I'm going to stagger my plus or minus signs, starting with the plus sign. And now in order to get my integral, I'm just going to multiply down these diagonals. Got x cubed times a plus sign times a minus cosine of x. So my first term is going to be negative x to the third cosine of x. Multiply down this next diagonal. 3x squared times a minus sign of x becomes a plus 3x squared sine of x. Down this diagonal, 6x plus sine and a positive cosine of x becomes plus 6x cosine of x. And then 6 times a minus sign times the sine of x. Now I've reached the bottom of my right-hand column, so I'm finished writing my integral, and I add my constant of integration. And there's the integral of x to the third sine of x. Like I said, we could do that using multi-step integration by parts, but we'd have like line after line, and the lines would probably get even too long at the end of the process on our paper to find this integral. Alright, let's go on and do the last example here. We're going to find the integral of x to the fourth cosine of 2x using tabular integration. And so we've got u and the derivatives, dv and the integrals. That would be a great name for a band, dv and the integrals. Alright, anyway, I'll fill my u and my derivatives in. Alright, and I'll fill my plus and minus signs in at y. And I'll fill in my dv and my integrals. And let's see, the integral of cosine of 2x is going to be 1/2 sine of 2x. Don't forget to apply the chain rule in reverse when we're taking these integrals. And then the integral of 1/2 sine of 2x is negative 1/4 cosine of 2x. And then negative 1/8 sine of 2x. And then positive 1/16 cosine of 2x. And positive 1/32 sine of 2x. Now that I've established my table, it's easy from here. We multiply down the diagonals. So we've got 1/2 x to the fourth sine of 2x. Multiply all this stuff out on this diagonal. The minus signs cancel each other out. The 4 and the 1/4 cancel each other out, and we end up with just a positive x to the third cosine of 2x. On this diagonal, we get a minus 3/2 x squared sine of 2x. Down this diagonal, and then we get a minus 3/2 x cosine of 2x. And this last diagonal, we get a plus 3/4 sine of 2x. And then my constant of integration. And there's my integral of x to the fourth cosine of 2x. And that's how we use tabular integration. See you next time.